いや、みんなこんにちは。おはようございますが、このスピーチでの日本語は以上です。後で英語でまた日本語下手ですから。はい。So my talk is unlocking Python's core magic. And if you want to follow through the slide deck, this is the QR code to the. Why it's not actually doing anything? Let me try this again. Yeah, that should be. It's not working. So anyway, I'll just use the keyboard for it. So this is a QR code. I'll stay here like for 10 or ish seconds. I know why it's not working. I still see a few cell phone, maybe 10 more seconds. Okay, 3, 2, 1. Okay, have anyone heard of committed tools? And so this one is actually a tool that's building up a commit message standardization, and you can automatically generate changelog or bump your project versions to this tool. And it would be great if you can like, subscribe, and contribute to the committed tools. And another project is Apache Airflow. So basically, this is a ETL pipeline framework. And it would also be nice if you can like and subscribe to this one and contribute as well. But if you look at the description, you might say, hey, are you going to talk about like the core Python stuff or add this some standard library things? So you're not going to talk about the third-party libraries? Kind of, but actually, no, I'm not going to talk about that. The core will be still the magics and also the standard libraries where we can use, but I will use these two projects as the example of how we can use this technique into those stuffs. And if you are there, yeah, this talk is actually kind of inspired by this super awesome talk by James, like, when was it? 2017? So it's 7 years ago. Yeah, time flies. And yeah, so because this slide has more than 100 pages, so I probably talk too much. Yeah, inspired by James as well. So let's start with Thunder methods. What actually is Thunder method? So these methods are just the methods with double underscore before and after that. It's named as Thunder method because of the Thunder double underscore. And it's some of the way for you to customize your Python class in a way more Pythonic, because these methods are actually coded implicitly by Python. You probably never will actually code it directly, mostly, yeah. And there's no name Thunder method in the official documentation. It's actually named as special names. And here's the list of Thunder methods, and we are not going to dig into every of them. And yeah, that this is actually collected by Thread, and I feel this article is quite good. And if you are following my style, there's a link here. So yeah, let's start with something really easy. Who here haven't ever used Thunder init? Could you please raise your hand? Oh, nice. Then I believe this one is still useful for you, but I'll go with this one probably really quick. Yeah. So basically, this is an example of how it's used. So there's a Thunder init here. We are assigning some attribute as the instance attribute. And so this is how the minimum use case of it. You create a class and use a Thunder init and add an attribute to this instance. You can also do some operations as well. So at the end, you can see you can get the example attribute here. And it's a method coded whenever a class is initialized. And it's also well known as the constructor of Python classes. If you come from other language like C++ or Java, you might heard of something like this. But, well, actually, it's probably not the constructor of Python class. It's actually the initializers of Python class. And how it should be used is just mentioned in the previous pages. This one is probably more like the constructor of Python. Dunder nude and how it can be used. This can be defined this way, and you can do some operation before the class is even created. And let's see another example so you have a better idea. So like this one, if you define a Dunder method when the class is passed, you can do some check, or you can check the argument that's passed into the class. So for this one, if you pass an integer as the first argument of this class, it will actually return an integer itself. So if you look at the last line, it's actually an integer. And we actually use it in Airflow. In xcount args, we use this new because xcount args is kind of deprecated. We don't want to use it anymore. So if anyone's calling xcount args, then it will actually return plain xcount args. But we still need to keep the xcount args for backward compatibility, because older version of Airflow might still use this one. But yeah, we want everyone to use plain xcount args or other xcount arg subclasses. And when you can use this Dunder nude, well, that's maybe you can want to do some operation before the class creation. And more concrete, I would probably suggest you don't use it if you don't know where you should. Yeah, this is something really error-prone, and if you don't take care of the detail of it, it might cause trouble that is not that easy to trace. So, yep. The next thing is Dunder call. So this method is coded when you want to call your instance as a function. Yep. And here's how it's used. If you define a Dunder call, then in this example, we'll just print this message, and you can initialize initialize an object from the example class, and you can just call it, and you will print the message. And we're actually using it in commutation tools. It's not the whole function of this Dunder call method, and why we are using it. The reason why we want to use it is we define all our commands through dictionary-like tools, and our function is the commands that it needs, which is a class, because we want to collect all those logic into our class, and we want to code it through this arg func and try to pass all the arguments into this one. So this Dunder call stuff can be used whenever you want to call your instance somehow. And yeah, this is the actual easy thing I would say. Dunder stir and Dunder IPR, I guess that's pronounced as rep or something. So basically, these two are the string representation of objects. And the difference is, for stir, it's be coded by stir, format, and print. And repertory will be coded by repertory. And which means the underlying stuff is that stir is kind of an informal way, and it could be used to print something more fancy. But for representation, that's one you should print something that's supposed to be a valid Python expression. So yeah, for this one, the string you return in the stir method is not actually something Python can run. If you put this line in Python, it will just break. And for repertory, that would be an example, which is a Python class initialization. So yeah, this is how it would look like. And by default, if you loop through, not actually loops, if you use a list comprehension in the class and you want to print it, it will, you'll be able to get a representation of the objects. So if you want to make your list comprehension look nicer, you probably need to define your Dunder repertory there. And this is an easy example of Airflow. We just return the string in another way so that we can do some operation. And yeah, for this one, we add a new class dataset alias, and we want to represent it in a better looking way. So this thing can be used whenever you want to print your object, nicely. And the next thing is operator overloading. It can be either Dunder equal, Dunder add, Dunder add, and or, and everything like this. And it will be coded if you use this kind of operator, like equal and or. So the best example in this one is define an equal method. If the other object you want to compare is an example object, will just always return true regardless whatever attribute inside it. And if not, we'll return a non-implemented and that the other object to do the equal comparison check. So yeah, I probably should define an init here, but that's skipped in this case. But yeah, you get the idea. Even though the two objects don't have the same string attribute, but if you compare it, it will return true because this is how they define here. Whenever both objects are example, then we should return true. And yeah, this is fairly easy. We also use it in Airflow because we want to compare where another data alias object with the same name is actually the same stuff. But yeah, this is later removed because the library editor already have it implemented. And this might be something look a bit more interesting. We are defining an AND method here, which allow Airflow to use the AND operator like this one. So when we use this operator overloading stuff, basically just if you want to leverage the Python operator and use and make your class look more Pythonic, and then you can use operator overloading. So next thing we are going to talk about is PEP 562. Yeah, module level get attr. But the fact is we are going to focus only on the module level get attr. Yeah, we'll skip the third one. Yeah, before we actually dig into the PEP, we'll probably need to know what get attr actually is. So it's basically something will be coded when you cannot find an attribute in the class. So if you are doing something like this, there's nothing defined in the example class, and you are still trying to access the non-existing attribute, then Python will raise attribute error because it's not defined. So if you define a get attr here, it will return this is not the attribute you are looking for. And when you try this again, yeah, you'll get a string here. So what does this mean for a module level get attr? Yeah, it just means something similar, but just for module. If a module is unable to find a specific attribute, it will just do all the operation you defined in get attr. And this is the example. The module is example.py, and whenever you try to get attribute not exist in example.py, yeah, it's always not exist because there's no other attribute here, and you will return a string. There's nothing in this module. The only thing you get is this message. So if you import example, and it will just print the attr, and if you try another attribute, it will still return the same message. And in Airflow, we use it in two use cases. Like this one, we'll deprecate a global variable. If you are calling the old version, we'll still return the new version, but we'll warn you, hey, this one is probably not something you should use, and probably will be deprecating in the next version. So that's how we can deprecate a global variable. And the next thing is lazy import. So if you import Airflow itself, pretty much everything is not actually loaded until you actually need to access that value. So that's actually handled here. If the module, like if you import Airflow, then you access the attribute like DAG, it will go into the get attr and try to load the airflow.dag module. So yeah, when to use this one, if you want to handle the attribute missing, and yeah, the two use case is probably most common. Yeah, is that you can deprecate a global variable and do some lazy import because some of the module might be really heavy. Yeah, so the next thing is try except else. Yeah, if it happens if there's no exception occurs, then it will execute the else block. And yeah, it's something like this because the try block there is only a pass, so it's always go to this block should be executed. And this is actually using Airflow as well, but yeah, the logic is pretty simple and straightforward, so I'm not going to dig into that. And you can use it whenever you want to do something when exception do not occur. And my suggestion is that you can move the logic that's don't supposed to exist in try block, because many people might write the try block really huge, but only one line of them would contain the code actually raise an exception. So I'll probably do something like this. If you try to divide a number and return the result, we can use the else block to return the result. The fact in this example, you probably don't even need the else block because you can just return it. But yeah, this is just an example on how you can move irrelevant code into the else block. And there's also a for else, but I'm not going to dig into that yet. So the next thing is decorators. Basically, decorator is a function that takes another function as an argument, and you wrap around that function. And what does that mean? So for this example, this is a function we pass into the decorator, and these two lines are the so-called wrap around the function. So before you calling this function, you'll print the message above, and after you call this function, it will print the next line like after calling the function. So the result will be something like this one. So 3 is the logic here. We'll print whatever we add, the two number we add, pass into the example function. And under the hook, the decorator syntax is just you pass a function into decorator and assign it back to the example function. And if you are ever try to implement your own decorator, I would suggest you just using functional wraps. It will save a lot of potential trouble. Yeah. And here's an example of the airflow. We have a lot of duplicate code. So basically, this line are pretty much the same among a few classes. And I tried to extract the logic here and implement it as a standalone decorator. So later on, I just add this decorator to all those methods. So that's how we can remove all these lines. And yeah, so when you can use it, if you have a lot of common logic in like pretty much all of the methods, then you can use a decorator. And yeah, PyCon already have lots and lots of decorator talks, and they might dig into some more use cases. So you can find it there. It's put pretty much everywhere. And the next thing is functool, or just functool the partial. Yeah, because functool, there's a lot of different tools you can use. So I'm probably not going to have time to dig into everyone. Yeah, this is functool the partial, and this is used to freeze a portion of function argument. And yeah, again, what does that mean? So in this example, we defined an add function, which just return a plus b with, yeah, simple enough. But if we want to implement an add 1 function and add 2 function, we can fix the b value as 1 and 2 separately. And you can use your function like this way. Yeah, add 100 and add 2. You don't need to pass the second argument. Yep. And of course, this is used in Airflow as well. Yeah, but there's an error there because it is supposed to be true, but I create another pull request to fix that. So the code here is actually we fix the value use async. So we now create 2 functions based on the underscore get default Azure credential. So it's much easier for us to create 2 functions it's pretty much the same, but yeah, only one argument is different. So that's when we can use this 204. And the next thing I'm going to talk about is iterator protocol. And before that, we probably should briefly talk about what an iterator is. So an iterator is something that repeatedly calls the dunder next inside it and will return the items inside it. And it will raise a stop iteration exception whenever there's no more data. And you will also need to define a dunder iter inside it. Yeah, just return the iterator itself. So that's iterator. And here's iterator protocol in Python documentation. And these two methods are needed for the iterator protocol stuff. You'll need to first define an iter that return the iterator object itself. And the next thing is the counter next. You'll need to try return the next item every time till it's consumed, and you then raise a stop iteration exception if there's just nothing to return. Yeah, this is a basic example of this one. We have an attribute iter items, which is just a range of 0 to n. And for the counter iter, we just return this iterator object itself. And the interesting part is the counter next. So we'll first try to return the next self.iter items. And if there's nothing we can do, then we'll just raise the stop iteration here. Yeah, so that's how it looks like. If you run through, like for I in example 5, which is pretty much range from 0 to 5, and after it's consumed this iterator, it will print stop routine, just like defined here. And yeah, this is used in Airflow, and why do we actually use it? Because we want to mark a special case where GCS blobs get new attributes when it's consumed. So because before this operator is consumed, you won't be able to get the prefix or the next next page token in this object. So this is somewhat interesting behavior. So that's why I use this iterator protocol. And speaking of when to use it, whenever you want to make your class an iterator, I think, this is pretty much the only case I ever used iterator protocol. But that's the idea. So the takeaway of this talk is introducing some of the technique you may or may not know already. And I try to give some minimum example. And I try to showcase how this technique can be used in real-world use case and mostly just open source. Because if it's closed source, I can't just show you, right? So I actually learned most of these techniques long ago, but when I need to actually use it, I just forget about it, or I'm not sure where I should use it. So I hope this talk can give you some of the knowledge this technique actually exists, and the confidence that these techniques are actually real and they are actually useful. And oops, I guess I just did not introduce myself yet. So I'm Wei Lee. This is actually the first time, technically the first time I spoke at PyCon JP, and I'm from PyCon Taiwan, also part of PyCon APAC. And if you want to connect with me, that's my GitHub handle and linking. And the reason why I talk about commitment tools and Airflow is because I'm the maintainer of commitment and committer of Airflow. And this Python script doesn't actually run, so it raises an error. And speaking of PyCon Taiwan, the PyCon Taiwan will actually happen in September 21 and to 23rd. Yes, I forgot it's already passed. And we actually had a good time with some folks from PyCon Japan and many folks from elsewhere. But here's the number of folks from Japan. Thanks. And next year, we'll go back to Taipei. And if you want to follow all the message, this is where you can find us. We are on Facebook, Instagram, and Twitter. And I'm also kind of from PyCon APAC, and PyCon APAC is going to happen next month. So it's happening in Indonesia. And we have a booth there, so you can just find us there. And tomorrow, it's tomorrow. Tomorrow will be a PyCon JP Spring, and I'll probably be there leading Airflow, but sorry about that. I'll be pretty late. I'll arrive 11:30-ish, so sorry about that, but I'll be there. If you are interested in how to contribute to Airflow, you can chat with me. Or you are interested in commitment, you can reach out to me as well. And it's the 133 page. I guess I also talked too much. And thanks, James, for the awesome keynote. And like talk too much thing. Yep. Yep. If there's any question.
Yeah, I think we still have a time for questions. Anyone? Yeah, James, let me pass you the mic.
Check. Thank you for your talk. For somebody who wants to learn about these features of Python, would you recommend that they start with examples from open source projects, or will those examples have or require too much background knowledge in the details of a project like Airflow?
For the very first start point, I would probably suggest like going to some minimum example, and I would suggest just watching your talk from 2017. That one can get you some idea on decorate. I believe there's decorator, meta class, and two other things. I think it's descriptor and another thing. So you can have some basic idea on how this stuff works. And next time, maybe you can take a look on this open source project, because you know they exist, but somehow, at least me, I don't actually believe, hey, is anyone going to use this one? So if you ever ever read this kind of code exists in an open source project you ever use or you interested in, then you have more confidence, hey, this thing is actually useful for real world use cases, and later you can bring it back to other open source project or bring it back to your company, and being a more Pythonic guy.
Any other questions? Seems like no. Okay, but I have something to say.
Oh.
Yeah, I think that's all. Thanks for your time and giving a great presentation. Give it a big round of applause to we guys.